Bhooshan. Speaking to Theodore about Shajay, he said that there are a few people around who have more expertise than he does within the field of architecture that he engages with, computation and digital control fabrication, including robotics. And Shajay has been very generous this afternoon, arriving early and advising us on questions that we have with respect to the use of robots. I'm sure it will vary from that which you might, well, I'm not sure, it might vary from that which you do in your daily engagements. Shajay heads the Computational Design Group at Zaha Hadid, and he has done so since 2007, when he also started at the firm. Working with Shajay's 10 permanent employees, so he runs, so to speak, an office within the office, and the responsibility is basically research and experiments to make sure that the office is continuously fed with those things that they strive to embody in their architecture and stay basically on the crust of developments within architecture with respect to these things that are at stake. Shajay is from India. He finished his bachelor there in 2002. He went on to study at the AA in the Design Research Laboratory, where he was amongst Theodore's first students, 2004 to 2006. He went on to do an M.Phil, University of Bath. Is that correct?
Yeah.
Yeah. That he finished in 2016, and then immediately thereafter he also engaged as a PhD candidate at the Block Research Institute at the ETH Zurich. So all of these things point obviously to that expertise that I initially stated, and it also involves Shajay and his partner being studio masters at DRL right now, teaching these things to students equivalent of what many of you are here. So, needless to say, the things that we are today privileged to be told about outlines one trajectory of contemporary development and basically state-of-the-art of expertise within architecture. Shajay, I'm delighted that you are here and looking very much forward to it.
No, thank you very much. Does this work? Yep. Yeah, thank Johan for the invitation and also being very accommodating to my erratic schedule. And thanks all of you for turning up earlier than your usual. And hopefully this is the first of many visits now that, as Johan mentioned, I was Theo's first student at the DRL when he was a tutor before he went on to become the director like a year later. So when I first met Patrick after DRL, like Patrick was on a sabbatical at that time, I was like just happy that like someone could give me a job on like the things that we all were really excited about. Like, you know, it was the early days of like digital design in some sense. Like, I mean, already the discipline had invested maybe 10 years by then, but I was just grateful that somebody thought like I could even lead a team without being tested, and to that like I'm always grateful to Zaha and Patrick that they have allowed me to grow and learn with the job. So in many ways, like all of the affiliations that I have since fostered, whether it's like at the DRL or at Block Research Group or studying at University of Bath, is stemming from that desire to be a true polymath, in the sense that which I think architects should be and or traditionally were. Kind of polymath in not the sense of being expert in everything, but like to have enough knowledge to be able to orchestrate and talk to many collaborators and many disciplines that are necessary ingredients to produce architecture. So the lecture today is mostly kind of basing, it recounts a history of the last decade or so of the work of the team that I lead, the Computation and Design group, but also like questions we are now beginning to ask, what to do with like all of these expertise, like how do you address the principal underlying questions of architecture, like, so in other words, beginning to ask the question where next, like to considering that like digital design and digital fabrication has had like a period of maturation of at least 2 decades, if not more. I mean, of which we have like lived experience of like about 11 years of that. And in many ways to begin to consider the original question that people like Cedric Price asked, like if technology is the answer, how do you formulate the appropriate question? And in that sense, like, it also, the belief is that like the answer to that question is not, fundamentally it's not a technological question. Like the questions have to be formulated outside of the science that is digital design and digital fabrication. So there's like lots of technological aspects, there are lots of scientific aspects to this, but like the questions underlying are indeed a social. That's our belief, that like we need to ask what is the social value proposition of these things. In other words, why should society care? And that's why should they care about the work we do, and why should they care about the output that we produce? And in the context that digital design and digital fabrication is rapidly maturing, right? So again, a brief philosophically also there's the work of the studio, and like particularly Patrick, who tries to formulate like the philosophical background for the work, comes from like the tradition of analytical philosophy, and where it does see this kind of distinction between the scientific image that human civilization has about the world, and the scientific image contains things like atoms and neurons and proteins, and basically it's a language which is descriptive and explanatory. Like it allows us to describe the world that we see and why it works and how it works, etc. So it's a kind of exploratory substrate upon which you can build an understanding of the manifest image, meaning manifest image contains things and people, and cultural values, things we ought to do and ought not to do. And these are not scientific questions, and they can never be answered by science, because these two images are fundamentally distinct. They're two aspects of the world we live in and of the universe that we live in, and so on and so forth. So in that sense, the manifest image is a language of community and of individual intentions, things that are fundamentally what architecture, in a way, has to straddle these two aspects. That on the one hand, there are technological aspects, but then there are obviously more social purposes for architecture. And so in more realistic or practical terms, what that means is that like we have invested like 2 decades or more of understanding architectural production, meaning the physical world, and also considerable progress has been made in the science of things, science of construction, science of computer-aided design, and so on and so forth. And what we are now beginning to ask the question is like, how can you merge it? How can you straddle it? How can you have a synoptic, synergetic relationship between how architecture is consumed, meaning how do people use architecture? How do they perceive that? So in many ways trying to combine or to marry the social with the physical, and to marry the storytelling aspects with the science. And again, architecture is not like the first discipline that has to, in recent times, have to do this. Like computer animation had a similar background, and kind of computer-aided design started somewhat at the same times in around the 1970s as computer-aided animation. And you can see like over 35, 40 years of work, like now any Pixar movie competes not only on the technological aspects. There's a lot of technology that goes into making of a computer animated movie, but there's also a lot of storytelling aspects. There's a lot of emotional aspects, and like how many disciplines come together, many kinds of professions come together, and many kinds of constraints are kind of easily or seamlessly, not easily, but seamlessly merged and woven together to tell the story. So when you look at like the movie, you're not concerned how the hell did they simulate like snow. You're concerned like mostly on like what the story is being told, right? Like, and so likewise for lighting and so on and so forth. So this is the kind of outlook that we have, or always had, like this mandate to try and devote enough time to technology such that after some time we can suppress technology to privilege the social, privilege the storytelling aspects, and the delightful aspects of architecture, not just how things stand up and how things are made, but like, you know, how people occupy spaces, how they navigate spaces, etc. So in other industries also you can see this building on the substrate of like technology, and like when other industries have merged the social, there's been like a disruptive change. So for example, the automobile industry, Henry Ford and the Ford production line is legendary for how they organize the physical and how they organize the science of producing cars. But we think like one of the understated aspects of like the revolutionary changes or the disruptive changes is not in the first set of cars, which like already delivered all the revolutionary changes. It's in the second set of cars that like Henry Ford kind of orchestrated. Obviously, it is partly due to the production line and like the assembly line, and also the service manuals and the service economy and like all of these physical aspects. But also, what the genius of that endeavor was also to position the car as a lifestyle object. Like it wasn't like just a physical thing. Like it was merged into the social consciousness of people. Like it became something beyond like just a vehicle, right? Like, so in that sense, combining or positioning the car in people's lives has had like, and we can still to date see its effects on our cities. Cities are dominated or planned for the car. So not to say that that's a good thing in the 21st century, but to say by merging the technological with the social aspects of how, or combining the production aspects with the consumption aspects, they've had like disruptive changes or disruptive effects. Likewise, you know, when you look at like buildings produced by Gaudi and other architects of the time, they didn't try to promote these buildings as like digitally or fabricated in a nice way or like structurally amazing buildings. Like that's not what Gaudi said. Even though underlying that is like a lot of structural technologies of that time, a lot of computation of that time, a lot of math of that time, etc., and material progression, and etc., and also a lot of fabrication aspects, like how to make instruments to describe things on site, how to cut stone, how to joinery aspects, and so on and so forth. So there was already economy of physical production, like and structural aspects, fabrication aspects, similar to our time now. We're saying digital design, digital fabrication, but if we realize that like the underlying production system is in place, and then now if you're able to utilize this to begin to tell stories, begin to synergetically tailor our architecture to the social needs of people or consumers of architecture, like we will have a better chance of digital design being more disruptive than currently it is. Another person who kind of clearly realized this is Corbusier himself. Like the phenomenal success of the Maison Domino as a diagram is also because it built upon technologies of that time, like the Enebic patents on like how to make concrete beams and columns and the entire concrete manufacturing system, but that's not what Corbusier tried to sell. Like he tried to build an architecture on top of the underlying physical science and the physical technologies. And lastly, like somewhat of real heroes and sheroes for us are Rey and Charles Eames. They also early on invested a lot of time on the physical aspects, the material aspect. They bought this patent from the US Army about wet forming, steam forming of timber, and they installed one of these machines in their living room. And as they were a very materially based practice, obviously, but they were also invested equally in cutting edge digital technologies at the time. They were one of the earliest adopters of Mathematica, or at least supporters of the software and that way of thinking. But somewhere along the way, when they began to consider where should that go, when they designed these one case study house or contributed to the case study movement, they realized that like technology and the vocabulary of materials and techniques is only one part of a larger set of things that make up the puzzle. And the other aspects are like understanding of family, economics, production, servicing, distribution, so on and so forth. So, and we think we are at a similar stage right now after 20 years or so of digital design and digital fabrication. Like we have a vocabulary of materials and techniques that we can now begin to apply to address, let's say, more foundational concerns of architecture. So in that sense, that's why we think we need a language of architecture that is able to address these other concerns. And this language, to put it simply, Patrick is calling it Tectonism, but like it has relationships to the idea of tectonics, like Kenneth Frampton and others kind of position in the early decades of the 21st century, and perhaps even in the last decades of the previous century. Just put it simply, it means for us a kind of stylistic heightening or amplification of underlying engineering and fabrication processes. And even put it even more simply, is to make visible in shape how things are working structurally and how things are working, how it was fabricated, and how does it perform environmentally, and so on and so forth, right? Like, so just to physically manifest these properties of shape. So again, just to summarize like we believe there's been a necessary phase of suspension of disbelief. We had to acknowledge that like technology had to be discovered and enthusiastically investigated for a certain period, and that has kind of accumulated or like synthesized into this idea of architectural geometry as a language. And by architectural geometry, we mean geometry that is aware of how it performs structurally and how it is aware of how it can be made. So it's not geometry that has no idea of how it stands or has no idea of how it's going to be made. And we also believe that this is a cumulative and collaborative endeavor. It's not like for one architecture company, it's not for one architect. It is in that sense more scientific endeavor that we have to build on historic work and also work of other disciplines and like kind of synergetically forge forward. So the presentation is basically divided in these two parts, exemplifying these two parts. Like one part of like our efforts in our office to contribute to this movement or of scientific research and scientific and collaborative and cumulative research. And then now we are beginning to, I will end with like a few examples of like current work or where we are trying to apply this, which we're kind of saying it's a period of science plus what? Science plus environmental sustainability, or science plus social values, or science plus cultural positioning of things. So like starting with the first aspect of the let's say a bit more scientific research into shell structures, or digital design and fabrication of this. Like we started like already in 2006 or so with this idea of digital fabrication, and in 2006 digital fabrication meant a lot of manual work, which means like we assembled 2,000 of these kind of circles by hand and then like stretched it together to make a formwork on which we were intending to cast concrete, but we abandoned it midway because then we realized it's better to do it in fabric. Rather than make our own fabric, we decided to use existing fabric and like stretch it across bent pipes and then use that to cast concrete onto. So the benefits of this was that like, and this was made with students and like local construction help in India over a period of 10 days. What it meant that like complex geometries could be delivered on site, because like the person who stitched all the fabric together, he did so in a space of this table. He had no idea what he was actually stitching. He brought this entire formwork in a small bag, and on site, like he stretched it, and by then the shape was already described on site, meaning like the people who were laying these rebar reinforcements, they were also had something to guide their work. So there were no real drawings made. The only drawings made were for the unfolding pattern. As you can see there, and everything else follows from that. So it's a kind of digital fabrication, but in many ways, one of the key principles of digital fabrication we realize is like to simplify how things are described on site. If digital fabrication requires like thousands of drawings, like it's unlikely to be made, you know. So we did learn quite a lot about like geometry and like all these other aspects, which we continued. And along a similar time, a scaled up version of this was already being made in London. So you can see it is bent steel pipes, more engineered obviously, and more structurally calculated and more properly digitally fabricated and so on and so forth. But the underlying principle is the same. You bend some pipes, stitch some fabric, and stretch the fabric into place. Since then we have been relying on capturing the intuition of these complex shapes by making prototypes, and because prototypes can be scaled, and therefore intuition that you get by making the smaller prototype also scales. And so the prototype was like maybe 2,000 pounds, and the building is like 11 million pounds. So you know but the learning experience is almost invaluable in that sense. Alongside, we also like develop like our own underlying computational frameworks, like where we are able to design complex shapes. The user or the designer is only operating on something that is easy to manipulate, whereas behind the scenes we are computing or modifying these geometries so that they can be digitally manufactured either in sheet metal or in fabric or so on and so forth. So there's the design aspects that are taken care of by intuitively exploring something that's easy to manipulate, and the computer does what it's good at, and the human does what the human's good at. And this way of formulating the computational problem allowed us to kind of also seek synergies with the research that Philippe Bloch was doing in ETH. Again, as I mentioned, his own his PhD and his work is relating to use of computers to upgrade the same kind of techniques and tools like people like Gaudi were using in the 18th and 19th century. So the difference is that like these methods, which were historically accumulated, they're very geometry based, meaning you can calculate structural performance using just a compass and a ruler. So it is very intuitive in the sense you don't need all these deep mathematical calculations, things that because it already accumulates all of that into a geometric way of calculating structure, right? So, and that, therefore, we see a greater synergy between the kind of language we were developing with curvature and geometry-based language, and these geometric ways of calculating structure and geometric ways of enabling digital fabrication or processing of geometry. So, and there's also deeper synergies with like these physical models, right? Like, and you can see, again, scale models, if this one falls, we know for sure the bigger one is going to fall. So in that sense, these are not representational models. These are actually scalable models, and eventually that model did stand. And then we're yet to build a fully scaled up version, but like, you know, so these are, again, explorations by students. This entire model stands up not because of glue or anything, but because of the string that is going around the boundary. It's holding everything in compression or by tensioning the boundary. And so if you cut that tension tie, everything falls down, similar to the previous model. So once you start with the simple ideas, like you can then quickly expand on the tectonic language and the geometric language and make it more spatially expressive. We're yet to find a client who wants to build this, but we think like it would be a progression on the kinds of things that Philippe already built in the Venice Biennale in 2016. So it'll be entirely in compression. There won't be any glue and there won't be any reinforcement. Nonetheless, it marries structure and fabrication and a fluid language of geometry, which is very much in synergy with like our own intentions at Zaha Hadid Architects. Similarly, with 3D printing, we've been kind of trying to explore this idea of like how do you develop an intuitive way to compute structure and compute fabrication aspects. So again, we are saying if you think of 3D printing as a scaled down version of masonry, if you think of all the layers of concrete as like just scaled down bricks, you could begin to capture some of the intuition that comes with assembling bricks. And we are trying to adapt methods again from historic masonry construction and trying to adapt it to something that's like as new as concrete printing or other clay related materials. So, and we're also, I mean, these are early prototypes, like to see like how far we can push this analogy between brick building and like layers of concrete. alongside, we are also discovering new operations that the computer can add to this mix that can allow us to make more complex shapes, which nonetheless retain some of the intuition of masonry and masonry construction. So if you think of Nubian vaulting, where you lay bricks layer by layer, and concrete printing is basically the same thing, just done by a robot in some sense. We've been doing similar kind of fabrication-aware or structure-aware geometry for other kinds of fabrication methods. This is printing in plastic, where the underlying shape is cut by a robot, and the formwork is assembled, and then you print on top of the formwork. Again, we try to do physical tests and when you do that physically, you are able to then devise a kind of computational workflow that captures some of that intuition, and therefore, you can build very quickly more complex things from very simple initial experiments. And we were able to then use robots to do the printing on top of the formwork. So all of these complex workflows that we put together, they start from a simple physical experiment, right? And this is how the robot then printed on top of a drum. And you can see the drums were hot wire cut, and hot wire cut by a robot, and then the printing was done by another robot on top of that formwork. You wouldn't have seen that it is a complex process like this if you just saw the shape. That's our intention, to make it seem seamless. And this entire project was done in a space of 3.5 weeks. And the hot wire cutting manufacturer was in Denmark, the 3D printing manufacturer was in London. There was not a single drawing made. Things were just hopping from one computer to another, from one robot to another, and and that's one of the key aspects of digital design and fabrication. You have to orchestrate and manage all of these exchanges between machines and between people. Similarly, for 3D printing at a smaller scale, in this case, these patterns have a structural meaning. And this utilizes what is called topology optimization, or a technology called topology optimization, which basically reduces material from where it's not needed. Similar to our bones, it will put material where there are more use and more stress, or more structural stress, and remove material from where it's not needed. So in many cases, you can remove up to 70% of material for the same structural strength. So you're basically making a lightweight version of the same geometry. So in the previous images, we wanted to highlight these things and to develop an aesthetic language around these processes of optimization and fabrication processes. And similarly with origami, we've been doing sheet metal manufacture, trying to rediscover historic techniques in origami, curved origami in this case, not straight line origami. So the principle is exactly the same. Instead of a straight cut, you put a curved cut, and you can get curvature for free. And this used to be taught in the Bauhaus, and even historically in many of the construction schools. Currently, a professor in MIT is exploring how to computationally and digitally recreate these processes. So equally, mathematicians are interested in origami, David Hoffman on my right, and artists are interested in this discipline, like Ron Resch on my left. So these are kinds of disciplines and endeavors that we very much attracted to, where not only there is a science, but there's an art aspect, and so both kinds of explorations are synergetically contributing the progress of that tectonic language. And recently there have been also people trying to recreate this in digital means and digital simulations and so on and so forth. But like the simple idea is this, right? Like you have to capture this intuition. You cut away material or put some lines, score paper or metal, and you fold it. And as a designer, within half an hour, you can create all of these varied shapes, which already incorporate how it's going to be physically made. So the shape has not only structural meaning in the fact that you can fold it, but also has physical fabrication meaning in the sense that you can scale this experiments from paper to metal, which is what we did. Again, with students, each of these eggs were put together in like a matter of 4 hours, and all we needed was a laser cutter that cut sheets of metal, and you fold them together and you assemble these kind of shapes. And I mean, of course, there's a lot of computation involved, but we want to suppress those aspects and kind of capture the intuition of physically working with these. So I did my M.Phil on this topic of curved origami to try and capture some of these underlying production systems associated with origami, and therefore we were able to put together a kind of workflow to create this large installation for the Venice Biennale in 2012. It contains 499 or 490 panels, which are all curve folded and assembled together. What you don't see in that simple structure is like this complex digital design and fabrication processes that have to be managed seamlessly. So that's curved origami, and likewise we've been kind of doing new things with exploring stone manufacture with carbon reinforcement. So the black is carbon fiber and the white parts are stone. Again, combines kind of tectonic ideas coming from the Wegener chair, and also structural ideas coming from the tension experiment that I previously showed. So this structure is held up only because of the tension tie that goes around the boundaries. So if you cut that tie, everything comes down. So we've been exploring these kind of ideas of manufacturing and structure and how we can synergetically combine that into a kind of aesthetic language to heighten and to physically express these aspects of structure and fabrication. So you can see those cut lines are not arbitrary. They're there to heighten and express the structural flow of forces. And the carbon fiber is on the inside where there's tensional forces, and the stone is on the outside, which is good in compression, where there's so that's the kind of exploration that we like to conduct. Similarly with this pavilion, lots of manufacturing constraints, spatial constraints, aesthetic constraints, so on and so forth. But what's interesting about this is just one person from our team is able to manage all of this complexity. So just to highlight that things are maturing so quickly, what used to take entire teams and used to take months of research and development are now being able to done in a matter of weeks and by smaller teams, meaning to say we can do something else with our time. Again, some of the structural simulations, and also how to make sure everything can be unfolded, so you can bend the steel skin onto a steel underlying structure. So there's a lot of fabrication complexity which we want to deliberately kind of seamlessly hide, but heighten other aspects, the shape aspects, so on and so forth. And again, even to this day, digital fabrication still means a lot of manual work. So this was produced in China. The first version was produced in Germany. The second and third versions are being produced in China. So all of this, in many ways, these experiments and prototypes are deliberately not acknowledging the architectural side of things. It's to suspend disbelief that like once we get those aspects under control, like we can begin to address more architectural concerns of program and spatial aspects and so on and so forth. Like, so this was one of our first major projects for my team, which unfortunately is currently on hold. Which we started design work on this already in 2013. We've kind of tried to heighten all of these aspects of structure and fabrication and ornament and all these aspects, as I mentioned. Like, so behind the scenes, there are all these computational workflows, ideas of BIM. It would have been like if it were completed, one of the kind of prime examples of like digital design and fabrication kind of maturing. But regardless, the status quo, regardless of whether projects like those have been manifested, is this, that research units like in ICD in Stuttgart or Philippe Bloch in ETH Zurich or CETA in Denmark, all these places are already knocking on the doors of doing these kind of pavilions in time-efficient ways and financially efficient ways. So which means, and there's also a kind of new aesthetic associated with these digital design fabrication methodologies. So in other words, you see more of these pavilions pop up across the world. It's not only in these elite, state-of-the-art research institutions, which begins to beg the question, you know, how can we apply some of these research into commercial projects? Like we did, again, my small team of 4 or 5 people worked on this gallery for mathematics, which we completed and which we are calling an interim result because it's an interior application and it's a small gallery of 1,000 square meters. But regardless, it was managed by like 5 people, and since the time it has opened, it's already invited like 1.2 million people to a gallery, gallery for mathematics. That's quite a lot of people. But more importantly, for us, for things to become architecture, people have to begin to occupy the things that we design, and that's why we're calling this an interim result, because it only highlights the digital design fabrication aspects, which we now want to use this as a way to address the social aspects. Just to briefly go over these digital design aspects, we made these fabrication pods, fabric pods. The technology is advanced far enough so we can manage millimeter precision, like the behavior of fabric, how to cut fabric, how to bend these pipes, and so on and so forth. At the same time, paying attention to all the objects which make a gallery. And so they were about 120 objects, and each one of them has its own story. And so we had to work with the curator whilst managing all of these technological aspects. The curator doesn't care how it's made. The curator only cares about what stories can be told with these objects. But that's what we want to highlight through that the discipline has come far enough to say that we can manage the technological aspects and then address what the client wants, which is the storytelling aspects. Yeah, we also made like a lot of physical models on this case also, small scale, big scale, and also work with the fabricator. So fabricator originally proposed that we should do this kind of fabric layout, which we find ugly. And because we made the previous physical model and we had all this prior research, we could propose to the fabricator and to the engineers that we can actually make the seam layout as we described it in the image above. And the final layout was like a negotiation between the craft of the fabricator and like our own digital practices. Likewise, for the benches, the concrete benches, instead of stone, it inherits a lot of stone cutting techniques, but instead of stone, using foam, and instead of like human labor, we're using a hot wire cutter or abrasion wire cutter. But the logic is very simple. It's upgrading historic techniques in stone cutting from a block of foam. You use a hot wire cutter to cut away everything that's not the bench. And you know, these are the various cuts from a block of foam until you get the bench. And then the foam is cast and the concrete is cast on top of the foam, and then all the pieces are assembled like so. There were 16 odd benches in the gallery, and each one of them was made by one designer and a few fabricators and lots of robots. So which kind of highlights like the distinction between traditional means of production, which means like you have to invest a lot of upfront design time, but the actual production processes are much faster. So those are the robots that got made, and like we are particularly interested in exploring these kind of tectonic or geometric language, so those cuts are not arbitrary, those curves are not arbitrary, like they're there for either structural reasons or for fabrication reasons. And so here's both of them put together. So to conclude then, so this kind of project-independent technological research then allows us to do many more projects, right? So this we did as a small gallery installation where, you know, the fabric comes down wherever people are not there, so it kind of encloses people. So, and how do we measure where people are? We just track where their feet are. So there's a laser that scans people's feet, and that's how we dynamically bring down the piston where people are not there. And then all these dots are projected that goes to the lowest funnel, and so there's a lot of technological aspects that we had to manage here, but like what we wanted it to be was a playful small room where people just walking around and think the fabric is coming down and like kind of engaging with them in some sense. And it was a small prototype. It was reasonably successful, reasonably because it was a small one, and not many people actually saw it because it was on the side of the main exhibition. But we felt confident enough to use this similar technology to manage the stage for the language of Figaro, so Marriage of Figaro, which was our contribution of stage design for the LA Philharmonic. So for every stage of the opera, like some parts of the fabric would come up and down, and like, you know, the actors and the singers would walk around on stage. And this was in the US, so you can imagine the kind of health and safety nightmares you had to go through. Likewise, like we feel so confident about these technologies now that we proposed a kind of school for refugee children. Unfortunately, I cannot tell you where it is for political reasons, but the idea was that like we will develop all the digital design and the shop drawings and hand it over to the local fabricator who can deploy these schools across the region. Again, this project is kind of held up because of political reasons, but we felt happy enough at least that some children were able to use these spaces before the winter came. So again, to highlight that like technologies are advancing so quickly, and that most offices have a good handle on all the complexities of digital design and digital fabrication, that we can begin to address other social causes now. So in other words, it is a period for asking what else can we do with this stuff? What other questions can we ask? Or to say, it's a period of science plus something, and most engineers and most engineering-oriented research practices will say it's science plus environmental sustainability. We should save the planet, like we should reduce resource usage and energy consumption should be reduced. All of that is important. But what we are saying as designers, as architects, what we can contribute is to use all of this science to address social and cultural value propositions and to study those value propositions equally computationally, equally scientifically. So not just to say it as a politically correct thing to say, but like, can you apply science and rational investigation to the social aspects of architecture? So for example, we are picking low-hanging fruit in that case. So in office spaces of this completed project, we are now going back and like kind of beginning to measure office layouts, like, how can we design flexible office layouts to account for meeting spaces, dynamically rearrange meeting spaces, and also address like relationships between people within a team, etc. So how can you design furniture to address how teams work and not work, etc. And where? So we're also beginning to measure from where you sit, like how many people can you see and how many people can you actually interact. And we're already developed the language of curvature. We're now beginning to measure socially what is the performance of this curved language. Previously we were saying curvature is good structurally, curvature is good for fabrication, and now we're beginning to say, like, once you have this language, how can you then use it to organize office layouts or spatial layouts? We are finding that curvature definitely offers more degrees, more freedom to organize these kind of social layouts, organizational layouts. Again, it's just, these are the lower hanging fruit, obviously, because it's easy to measure these kind of things. The other pet project for us is this idea of housing, and housing not in the sense of affordable housing alone, but like the social aspects of housing, meaning communal aspects of housing, and how can you computationally study how communities operate. So this is work with students of ours in the at the DRL, where one student team decided to address these communes that already exist in London. There are 4 or 5 of these communes of artists and manufacturers and other kind of vocations. And to that, like, they're applying the science of social networks, like Facebook, which is in the news for all the wrong reasons currently, but like you can use the underlying social technology and analysis technology to in a positive way as well, to and then combining it with like historic work of Bill Hillier and others in UCL, who are understanding physical networks using the same mathematics, let's say. So how do you bring social networks and physical networks together? So this particular team like mapped out like a few people in a given community and then tried to design spaces specifically for that community. So to computationally investigate social networks and then produce physical networks that kind of harmoniously house these people. So the names are changed, obviously. So again, applying the same rule-based way and the computational way, not only to address the physical aspects, but like now to address the social, relational aspects. How do you position people? Where do you put? Where should someone's house be? And so this used to be a very much a central task of an architect, like, or task of architecture is like, how do you organize social relationships in villages? Like the head of the village would be in a certain place and so on and so forth. So it's not to say there needs to be hierarchy, but like there is a relational marriage between the social structure and the physical structure of spaces. And obviously they're trying to combine like technologies of digital design and fabrication with the social side. So this particular team was trying to build on the ideas of clay printing and concrete printing, whilst also progressing the social analysis aspects. And so these are the hundreds of studies that they did on the physical. They weren't able to do that as many studies on the social side yet, but this was year one, and we are trying to build on this idea that like you can investigate the social side with just as much rigor as you can the physical aspects. So and also like to what is the aesthetic and what should these kind of spaces look like and what should they feel like and so on and so forth. Again, student work, but trying to marry all of these things as a prerequisite. Like it's not enough to just make some digital experiments anymore or some material experiments anymore. We are mandating students to say that like they have to begin to address the social aspects. Professionally, we are trying to hold ourselves to the same kind of sense of accountability. This is a website put together by IKEA and a few researchers, which is trying to collect data about what are contemporary preferences for people living in different parts of the world. So data technologies like Facebook and others can give you insight on what are contemporary preferences of living. You don't have to go by sticking your finger up in the air and say, oh, everyone wants a living room, or no one wants a living room, or social housing is better, or developer housing is better. You can actually check, gather this information. So we are also collaborating with like a housing, let's say developer slash provider, and trying to see which parts of their buildings are used when, how often, so on and so forth. So you can see there's event space, kitchen, bistro, cooking area, play area, and so on and so forth. So we are beginning to collect this kind of data to know whether whether you actually need a living room or not. And what's more important is to then visualize or make use of these data to say, how do you promote more engagement between people? How do you ensure that the architecture that you propose allows for greater interaction between people? So we are trying to say, if a person's daily schedule is A, B, and C, and he has to go or she has to go between these many rooms, can we force intersection of these paths? Like, can we force people to accidentally discover each other by the way we arrange these spaces? So that's the kind of intention. Like, this is still early work, but that's where we're going. And we're beginning to also address more developer concerns of like, how do you then sell these things, so on and so forth. But at the same time, we're trying to utilize all our language that we have previously developed to combine with these kind of data studies, because data on its own doesn't mean anything unless you physically manifest it in some sense. So ultimate aim, I will leave you with this video, is to make a kind of Tinder for housing, where you not only are able to choose your house, but you can also choose your neighbors, which is more important in a kind of social sense. That right, like so. Most people would like to live with their friends, obviously, but in contemporary cities, if you are especially buying a house, you have to buy where things are cheapest. So we see affordability in a slightly different way to say affordability, you should be able to afford to live with your friends, and how can we utilize and leverage technologies of data and technologies of digital design, digital fabrication to actually deliver social housing of this kind, not social housing from the post-war times when it was social housing meant like mass deployment of prefabricated units. Here we are saying customized units, customized to groups of people, and so on and so forth. So that's our hope. So I will leave you with this video. And I can take any questions if you have any. So thank you very much. No questions, then I can release you for your beers or whatever, and I can go to the airport.
Yeah. So what happens with the data of people in this app?
Yeah.
Because you have to collect
Yeah.
data, what people like. So how do you see that? Because I think your presentation is fantastic, but I thought it was a little bit too utopian.
Sure.
For the moment where we are now.
Yeah.
This post-utopian.
Yeah, post-Facebook, you mean? Yeah.
Where people don't really relate to the digital the same way
Yeah.
as they used to.
Yeah.
There's an idea that the digital cannot solve things.
Yeah.
There has to come some kind of a reimagining of what digital means.
Yeah.
So I would just like to
Yeah, I mean thank you very much for the question, and definitely we think that like digital, like people obviously are beginning, society in general, are not so comfortable with like the digital realm, and there's like anxieties about robots and anxieties about AI, anxieties about data. And there's a kind of backlash to say like, oh, we want like buildings that the way they were built like 100 years ago. But we think the answer is like not to go back 100 years, is to like look at like what happened 100 years ago in terms of principle, and to position digital technologies in a way to address social concerns, and that's definitely what we want to try and do, like to address the utopian questions again, because there's a lot of cynicism that has crept in, like which is not necessarily true of the technologies per se. It's just like how it got implemented, or like for every bad Facebook story there could be a positive story of like using the data, and like you can obviously keep it anonymous, like, and privacy matters can be easily addressed. And we think like, people are willing to give up data and contribute if they see the social benefit of it. Like if we can say we can leverage all of this technology to help people live together, live with their friends, like at least we think there will be at least some set of people who will want to try this as an experiment. And we don't know where that's going to go, like, but and in some sense it's not so utopian, because cities like London, it's already happening, where you can go and say developers are building rent-only housing, and what they give in return is like, it's a kind of membership, like you get a gym and you get, if you're a startup company, you obviously want to live with where other startup people are, because that's where you're going to find your collaborator. You're not going to find a collaborator living outside the city. So that kind of housing is happening, where people are going directly to startup incubators and saying, you already put these people together and they're working together, like why don't they live together? Like, because so it's kind of like co-work as like kind of also mutated to co-live. And so that's the social phenomena that's already happening. And so we think if we don't ask the utopian questions, that's going to end up in another kind of Facebook nightmare. So we think we should ask the first principle questions otherwise, we might leave the door open for cynicism. Yeah.
How important is context in designing housing, for instance? How do you bring vernacular architecture together with computational design?
Yeah, I mean, for us, ideas of vernacular are somewhat abstracted to these principles of structure and material and environmental aspects and also social aspects, right? So vernacular to us is not a style that we have to recreate Victorian style, but this is indeed vernacular in the sense that it is specific, the data is going to be specific to the people, or the material is going to be, the expression is going to be specific to the material that's available, and material and structure has always gone hand in hand. Like the churches of previous years, or mosques, and all of these religious buildings, in society invested in them. And that's what made it vernacular, we think. That's what tied it to place, that's what tied it to the community. And so vernacular in that sense is the science of vernacular. You can always abstract and computationally enhance, like we've shown. That's why we work with Philippe Bloch, who is working with historic graphical methods of calculating structures and adding the secret sauce of computers to it. But we also see benefit of using these techniques. If you can tie it to community, that's what ties it to place, and ties it to place and time. And essentially that's what vernacular is, right? To place, tie your architecture to place and time. So we share that interest in the vernacular, but vernacular should be also 21st century vernacular.
I have a question about the idea of, you speak a lot about the fact that you're trying to produce this kind of lifestyle, or looking at how we. So, is this, and then social concern, so is the concern only for the result that you have produced, for people to come and use it, or is there some involvement of people in the production process as well? Because, and I'm referring to actually, say you mentioned a story about when you all were doing the AA visiting school in India, you had a guy sitting on a 2x2 table and he just stitched everything together, but he had no idea what he was going to do with it. So is there any attempt at even looking at those ideas of social concerns? Because in developing countries like India, where it's so labor intensive still, how do we approach those situations of design?
Absolutely. In the sense that the kinds of I showed you two, one is fabric forming, the other is metal forming, and we pick these topics of or technologies of making for when it is synergetic on multiple axes or multiple dimensions. So there is the craft aspect. So you could use a robot and have really digital design fabrication of one kind, or if you're in a different economy, you could also use your hands and the craft and the labor that's available and the historic building craft that's accumulated in any region, right? I was saying similar with stone cutting, if we don't have the skill in London, so that's why we sent it to be hot wire cut somewhere. But if we were to build similar things in India or in Mexico, where we have built a few things, we definitely rely or try to incorporate the local building industry into the mix. And in many cases, these construction crews, they were so happy to make this because on an everyday basis they're making brick walls and plastering them. But they were just happier because they were engaged in this. So yeah, so we see a similar. That's also an intention why we are looking at 3D printing, which is supposedly new technology from the point of view of masonry, because then you can bring historic knowledge systems and intuitions into play.
Yeah. Once you leave from that side, like say for example, you did a project in Mexico. After you left, was the construction crew that you particularly worked with, were they empowered enough maybe to start doing it themselves? I'm asking
I mean, we don't know what happened to them, or not all the crews we know, but we do know the workshop we once did in India. So there was a student who then made a business out of selling fabric formed houses. Yeah, he now has a business where he then took that idea and like kind of trained his own workers, and like he contacted Philippe and asked like how to compute these shapes. Yeah, and he has a business. I don't know how successful that business is, but yeah. And similar with the sheet metal forming, because once you unleash that idea as an intuitive idea, like you say, you just score and you fold, you know, people can take that anywhere they want, like, because for us it's interesting to take it in a computational way, but like there are others who can take it in a kind of artistic way, or and as they've already done. And that's why I try to mention that it was taught in the Bauhaus. There was a handbook of curved origami to explore shape making in relation to the material, or in relation to the geometric technique. So what we're trying to remove the taboo of shape, as though, I mean, clearly there's a taboo associated with complex geometry. If you ask anyone, any student specifically, like we've done like workshops like all over the world, they're deeply fascinated by shape, but if you ask them, they will like, oh no, we're not interested in shape for the sake of shape. There is a taboo, as though you need like some other qualifier to explore shape, which I think like misses the point. The point is to get enough control over shape so you can use that to do other things. And other things could be engaged in the local economy, other things could be simplifying construction documentation, simplifying construction procedure, saving material, whatever it is, you know. Because you can't do all of these things with boxes. That's a simple way to think about it, I think, like that. You couldn't possibly address complex societal requirements with like simple geometry. Yeah.
I really enjoyed your presentation, especially the two installations that involve robotics and the textile.
Yeah.
Specifically, the one that it was kind of a symphony, it was involved in the theater.
Yeah.
I was wondering, did the movements also were controlled by the music?
No. No, yeah, it was more curated, so because it could be, because it's entirely digital and there are motors that it wasn't manually pulled, so there are motors and it's all digitally controlled, but yeah, for various reasons it wasn't controlled by music, because first of all you want people to be standing on it and singing, so an opera works, at least the Marriage of Figaro works in sets, or I don't know how they call it, scenes. So it was between scenes that like the singers would get off and then the stage would change and then they would get on again, and yeah. Yeah, so it could be, but it wasn't. No.
So it was already programmed and it had
Yeah.
like a specific time and performers were also...
Yeah, it was programmed, and like when the performance got off, someone hit a switch, and yeah.
Yeah, I enjoyed it very much. I would just like to ask, parametric system, that's very, as a theory, it's very self-explanatory. It can sustain itself as an architecture with its complex geometry, applied geometries. And there could be graph mathematics that analyze social relations in between their users.
Yep.
Law and subtractor for lightweight structure that is sustainable in difficult societies. So my question would be, because I personally went to the Galaxy Sofa in Beijing, and it was quite sad to find that about the third floor, or maybe 5 floors, it's quite empty.
Yeah.
So my question would be, how can applied geometry sustain itself not in the interior, but to its exterior social relations, like specific cultural groups like India?
Yeah, no, I mean, yeah, exactly, like Galaxy Soho, I mean, that are one of those kind of projects that like we are now beginning to question internally also, right? Like to say, you know, there are many successes that the project delivered, like remarkable speed of construction, technological advancements, and also bringing, upgrading the real estate value and of that area, and like so on and so forth. Similar to the Vitra station, sorry, not the Vitra, the BMW factory, etc. So, and also in Seoul, the Dongdaemun Plaza. But that's from a previous stage of our company's work. So architecture moves somewhat slowly, and like because construction is, you know, takes its own time. So whilst that is being happening, and we have to celebrate its successes, and but also be critical, like us, the kinds of questions you were asking about. Why was it that like how the top floors were not originally occupied, and so that's why we're now looking at like these kind of ways to measure potential successes, like, you know, would it be occupied? Like, because previously no one asked the question, would it be occupied? Because the developer wanted X square meters and we delivered X square meters. But like now we're saying that, like, you know, these, how do you socially activate these spaces? Like we need to have a computational way to measure or at least understand the phenomena of social activation. So we're at the early stages of doing that, but regardless, we need to, we think, like, not only put our finger up in the air and like kind of intuitively figure this out, like we have to study it as rigorously as we have studied the physical side. Yeah.
So thanks a lot for like really amazing work.
Yeah, thank you.
But what I particularly like is that there's like this really like productive tension between like kind of creating variation within the shape and at the same time having a sort of like, if you want, repetition that makes it recognizable as a style. And I wanted to refer to the last two projects you show and how you see this tension coming into, let's say, the social aspect. Because let's say from one side you have a building in which you're trying to increase interaction as much as possible. And from the other side you have this, let's say, Tinder for home, which somehow builds these communities in which, let's say, I live just with my friends. And I don't know, it kind of, to me, brings up a little bit this ghost of like, I live in a happy community with all my friends and I have no idea what happens.
Yeah.
And so I don't know how that like tension that kind of creates your work, like on, let's say, geometric fabrication level.
Yeah. No, I mean, yeah, it's definitely true that like we don't know where it's gonna go, but you know, we have to assume that people, not assume, we know people want to live with people they know. Like, so it's not, yeah, how much of non-people you know do you want to meet in a day is a personal preference, obviously, and a certain amount of that is necessary for society to function, obviously. But like, if you're only meeting people you don't know, then that's also not so good. So Or maybe that's even more disastrous than living with people you only know. And so, so there is that natural tension there. Like, so we, so it's the idea of mass customization, right? Like, it's mass customization in a way. The ultimate mass customization where every individual user is a market on his or her own. So there are as many markets as there are people. One level higher is that there are like 1/10 the number of markets as there are number of people, and it's like it's already better than like previous stages where mass produced. There was one house for all the people. So it's kind of trying to operate in that scale between how many different types of houses do you need? Like every house is different, or all houses are the same. So those are the two extremes, and you can occupy any segmentation in between. So, but we do think that not all segmentations are suited for digital design or fabrication, because once you reach a segmentation where there's only 3 or 4 types, it's best like you leave that to the developer, because they have mass-produced systems. Whereas on the other hand, if you go very fine, then digital design becomes not, there's no repeatability, and therefore there's no gain economically, or you're wasting resources. So there's a sweet spot for digital design and fabrication, and the kind of segmentations you need to what is the size of the community, for example? Should it be 6 people or 90 people? We don't know, but yeah.
So I was just wondering, considering there are a lot of practices within, let's say, people bounded by the architecture community, that use computational tools to various degrees. Would you say there are like specific, since you've been saying that it's a point in time where it's matured to a certain degree, would you say you can identify now certain sub-genres in computation? And if yes, then is there a practice that you would say is radically different from the way you work? And then what sort of...
yeah, no, absolutely. I think that's a very pertinent question, that there's a sense that like somehow computers erase the need for style, which is, or even erase the kind of mechanisms by which individual groups of people or companies develop their own authorship or ways of doing things. In fact, it's the other way around, like that, like it increases the possibility that you can have your own way. There's definitely so many more ways that you could do and customize the use of computers to suit it to your methods of working. For example, if you did privilege more the material side and the physical side, like obviously it would be very different. Like Hedwig, they use computers, but they use it very differently to us. Or like what I find most interesting is that like small young companies can compete shoulder to shoulder with like big companies because of the use of computers. Like there's this, I don't know how many of you know of this small practice called Panda Architects. I mean, they're small in number, but they're like huge in like influence in China, and they were in, he was a student in Vienna, like, and over 6-7 years, like, you know, I would say they've captured Instagram in ways that like bigger offices couldn't even imagine. And that's I think is the power of like digital design and fabrication, that there can be very millions of micro styles and micro genres, and like, so it's not, it's unlikely that there will be a single unifying style. You know, like there will be many sub, like the Bartlett is very clearly different, like in the way they're using digital fabrication and to the more continuous things that we are doing, right? Like, and they're more discrete or block-like.
Yeah. I have a question about the
Yeah.
I know that you said it's not possible to explain a lot, but it would be great if you could explain a bit about how the social principles that you had and how you came to that.
Yeah, with that project, there were no. Yeah, there was only a social intention, right? Like, I mean, so like, it wasn't studied in any computational way. But what was interesting there was that there were two groups of, let's say, two communities of refugee children speaking two different languages, and the school currently that they go to, they're from 9 to 12 is like one language and one set of teachers and one set of students, and then they all go home, and then the next language and the next set of teachers come in, and like, so there was a potential to study that, but the urgency of getting something delivered on site before the winter came in was so pressing that we just did that intuitively, right? Like, we said, okay, like, or more importantly, the physical aspects of deploying it on site and like making it cheap enough and easy enough to construct took precedence over the social aspects, which we feel like if that process could have been done many times, if that school could have been deployed in many places, there could have been a greater influence of the social aspects. But like, because it didn't go ahead, like, you know, we can only kind of see the physical side of things, which is, what was interesting about that is that, like, you know, it comes on site like folded like this, and like already the fabric is stitched, and then on site you just open it, and then it stands because of the tension. So yeah, the physical side there is more interesting and more prevalent, unfortunately. Yeah.
Let's say if you had time to kind of come to a proper way to collect this information about the social aspects that you need, like how would you go about it? For example, like the closest thing that I saw was this website platform, Refugee Republic, which somehow shows the live in one of the camps in Jordan and what's happening, how people are using the spaces.
Yeah.
That was the closest thing that I would find as a source of information.
Yeah, I mean the other social aspects to this is again, unfortunately, because of legal restrictions, like on refugees who you cannot employ them to build their own houses, which is very strange, because then they become employed. So some of these technologies, in a way, like, people could build their own houses again, in a way. Because that could be another form of deployment, but like currently that's not feasible because of various legal or questions of political philosophy, let's say, you know. So that's, again, not something that we have as architects any control over. So we don't want to address that. But it could be one more way to say, like, the community is involved in the making of their own spaces, and therefore it will become more suited to their community, and so it'll have its own unique expression of the same underlying technology. Let's say, like, it could all be fabric, but it will be already in the fabric different. And people will maybe put ornament differently, and like maybe they might stitch it differently, and so on and so forth. Like, so, so there are all these aspects that could be linked to the communal aspects, but like, for various reasons, especially in more pressing situations like the refugee crisis, etc., what takes somehow precedence is just getting as many houses built. And already we found it interesting, that's why we did it like that. It was not a house, it was like a school, like, because usually no one talks about in the kind of refugee sense that, like, they need schools. You know, like, they only talk about, like, oh, they need houses. But these camps are like there for 6-7 years at least, so obviously they need to go to school. You know. Yeah.
Regarding your last project, which was Tectonism.
Yeah.
I was reading some brought the idea of troll,
Trolls.
trolling.
Yeah.
And like how we actually just add people to agree with us and we continuously feed us those kind of ideas. And this has led to extreme polarization in the world. So do you think this idea of like, maybe I think this art, do you think this idea of living just with the conclusion or like we would add to this kind of polarization?
Again, we think that it's too complex a phenomenon to know what's going to happen, and we would need to work with social scientists and particularly computational social scientists to do simulations of like what might happen if you introduce a population of trolls. When do trolls cancel each other out? I mean, there are all these sweet spots, right? Like, when there are like too many trolls, like they have little effect, and that we can already see because they're kind of creating so much noise that they drown each other out. But like when they're only a small community of trolls, they seem to do the most damage. So all of these aspects make it very interesting, and like in many ways, we only have to tap into the technology and studies that are already happening. Recently, I met like he was a U.S. military trying to simulate how extremist groups, the kind of trolls of extremism, let's say, which of these extremists they need to take out to so that like the extremist group itself dies, So you can use the same nasty military technology like to better use. Yeah.
This is the same kind of effect.
Yeah. To study it in a more positive way, like the same. I mean, you could use the internet in good ways or bad ways, and the same. We think Tinder is a positive technology. They say Facebook is a positive technology. Like you could misuse it, or it could fall into misuse, but it could also really change the way we live. Yeah. Good. Yeah. Thanks very much.